Welcome to MOOC on Cartographic Techniques practical session. In this session, we will be dealing with Smith's relative relief method. This is one of the methods that is classified under slope analysis. In your previous sessions, there was a session related to a slope analysis on Wentworth's method. This method was calculated using the average slope, and in today's session, we will be dealing with calculating the relative relief of a given terrain. So, moving on to the snippet of this section, we have a basic introduction part where it deals with the introduction of relative relief and how the terminology evolved, who was responsible for the evolution and the time. And moving on to the preparation of data set will be the second part of this section. The third part deals with the calculation of relative relief, which is done by using the formula given by Smith. And in fourth part, it involves the preparation of relative relief map. Fifth is explaining about the real world cases and scenarios where relative relief is used. And sixth is the key takeaways of this particular session. Now, to have a basic understanding, before that we need to know what are the learning objective of this session. So, by the end of the session, you will be able to answer what is a relative relief and why is it very important to consider in the subject of geography, and how to calculate and map it using Smith's method. So, to start off with, we will say what is a relative relief. This is nothing but the actual variation of the height. So, in simple terms, we can say that it is a difference between the maximum height and the minimum height, and the key term here is per grade. So, what is per grade? This is nothing but a simple square. So, in general, there are a lot of methods where a whole study area will be considered and the calculation and evaluation will be done for the full study area. But in this case, what Smith tried to understand and analyze is, he divided all the squares into small grids. Once after he divided all these, he calculated and evaluated each small grid in order to understand fine refinements in any area. So, the next is, we need to understand a difference between the relief and elevation. By looking at the picture given below, we can easily identify. So, what is an elevation? Here you can see a relief feature of mountain and slowly it steeps down to the sea level. So, whichever data that is going to have a connection between the elevation level of a hill and the bathymetric data will be your elevation. But in case of relief, it is absolutely finding out the difference between two different reliefs that is present within a terrain. Say for example, if we have a plain area and we have a mountainous area, then the difference that is calculated between these becomes your relative relief. So, the term relative relief, it was invented and used by Smith in the year 1935. So, what he wanted to do is, he wanted to find the available relief in order to relate the altitude of a highest and the lowest points of any particular area. So, for this, in order to execute, he chose Ohio State, a state in US, as his study area. And once he chose his study area, he particularly draw grids of 2 centimeter height and 2 centimeter length. So, this is of importance and a very important key term that you need to consider in the further upcoming steps. Once after he divided everything into 2 centimeter into 2 centimeter grids, he calculated the difference of altitude. So, how did he do? He calculated the difference of altitudes between the highest and the lowest points of each square on the base map. Once after he has calculated, he entered manually the values and connected with the help of isoplates. Isoplates are nothing but, if there are points here of same value, say this is 100, this is 100, when we are connecting all these, this forms a line, and this we call it as isoplate. So, the next thing he did was, once after he drew the isoplate, the resulting map he gave was the relative relief map with the maximum relief and the minimum relief within that. So, why do we need to understand what relative relief is? How is it going to help us? In what terms are we beneficial in understanding the concept of relative relief? First is to understand the geomorphological characteristics and the history of a region, which is nothing but, if in case you would have heard about the formation of a valley by Davis and several theories that were given by several other geomorphologists. First, there will be a plain or any valleys that will be formed. The last and the end feature that is present will be a plain. So, what happens in the middle of this is the erosional process. So, this erosional process we will be easily understanding it with the help of the relative relief. Next is degree of dissection. This also is calculating the erosional process that happens in a particular area. Slope stability. This is one of the important part where relative relief is used in the real world scenarios. What is a slope stability? Imagine you are having a place where there are a lot of landslides and is happening, and in order to understand the basic slope of a particular area, we need to understand the soil characteristics and the nature of the plates that are present. To do that, we need to understand the relative relief of that particular place. The next is landscape evolution. As already mentioned, we have seen several landforms that start from the valleys and it ends very base plains. The next one is hazard assessment. As I already have mentioned, we are completely using relative relief in order to understand different sorts of landslides and even floods. This also is very important in terms of understanding the hazards and resource management and urban planning. The next is, when using Smith's calculation of relative relief, that is, you can also call it as a local relief, it helps us answering a lot of questions such as why most of the rugged areas are there in a particular region. What is the reason behind that area being very rugged, and how do elevation changes influence the erosion and other geometric processes, and how can we categorize and group and we represent it in the form of a map. So, these are some of the important questions that we can able to answer once after we are manually doing the Smith's calculation. Now, moving on to the manual process. The first step that we need to do is a preparation of data set. We are going to have a base wherein the calculation will be carried out. So, for this we need a topo sheet. So, first, topo sheet. There are two forms of topo sheets. This is nothing but a form which was available in olden days, and currently we are having it in online, that is in forms of digitals. So, in case of old series topo sheets, they are divided into 9 quadrants. The horizontal divisions are labeled as A, B and C, while the vertical divisions, they are numbered as 1, 2 and 3. And in case of new series topo sheets, it is divided into 36 quadrants, where it will be labeled from A to F, and the vertical divisions, they are numbered as 1 to 6. So, this is one example where you can see old series map, and here you can see it is divided into A, B and C here, and here it is divided into 1 and so on. Like the topo sheet, I have cropped the topo sheet. As you can see the full topo sheet, you will be able to see all the numbers to the side of the topo sheet. This is one example of a new open series map where, as I already have mentioned, it is from A to F, and here you can see 1, 2 and 3. This is one another form of a topo sheet where you can see a lot of small other grids present within this topo sheets. So, these are created in some olden days where a lot of information and details will be present, and in case of new series open topo sheet, more colorful and vibrant colors will be used in case of this one. Now, moving on to the step 2 of this. If in case you are working with an old series topo sheet, say the form 1 of the topo sheet as already mentioned, we will be having one single quadrant that covers a whole lot of areas. But in case of new open series topo sheet, it needs to be taken into consideration that we need to calculate 4 different quadrants within that particular topo sheet itself. So, let us see it with the help of an example. So, in case of form 1, as already said, here there is one quadrant that is placed above, and here the vertical division, only one quadrant is selected. In case of Dharmaburi district, both of the forms are for Dharmaburi district, and in case of this one quadrant includes a whole lot of information and contours, while in case of form 2, we can see that 4 different quadrants will be used for representing this much information. So, in case if you are using form 1, take into consideration only one grid, while in case of using form 2, that is new open series topo sheets, take into consideration the 4 boxes, that is starting from A1, B1 and A2, B2. So, once you are done with fixing the topo sheet and selecting the quadrants, the next and the most important thing is you need to place a tracing sheet on top of the topographic map. So, this is one of the key steps, as we have to, in the further steps, we need to trace all the contours on the tracing sheet. Once you are done placing the tracing sheet on the top of topographic sheet, you should begin by outlining the boundary of the selected block. So, in carefully selecting a block, you need to understand some things. Say for example, if there is a place without any contours, the concept of preparing and calculating relative relief will be of no use. So, select a quadrant which is having a good number of contours in order to understand what type of relief is present in a particular area. Now, after once doing that, we are going to divide that particular boundary further into 2 centimeter into 2 centimeter square grids for each thing. In our case, we have 1:50,000 topo sheet, and at the end of the topo sheet, you will be able to identify an information called 2 centimeter represents 1 kilometer. Now, what is this? 2 centimeter is nothing but the area that is represented within your topo sheet, and 1 kilometer is the actual ground distance in the real world. So, 1 kilometer of the real world is represented within 2 centimeter of the given topo sheet. So, this is the basic idea of dividing and having a square grids of 2 centimeter into 2 centimeter. Now, once you have fixed 1:50,000, but in case there are lot of other scales of topo sheet available, say for example, you have 1:25,000 topo sheet, you have 1:1 lakh topo sheet, and within that topo sheet itself, you will be able to identify that 1 kilometer represents 4 centimeter for in case of 1:1 lakh, and 1 kilometer equals 2 centimeter in case of 50,000, and in case of 1:25,000 it is 4 centimeter. Now, coming to the part of creation of base, as already mentioned, it is very important to place the tracing sheet on top of the topo sheet. Once you are done with placing the tracing sheet, the first step you need to do is carefully mark the boundary of your quadrant. So, once after doing this, you are going to connect it with the help of a ruler. So, once this step is executed, the second step, as already said, you need to draw a 2 centimeter into 2 centimeter grids, which you can do it with the help of a ruler again. So, you will be able to get small grids like this. So, once you are done doing this, this is one of the output that was already taken to show you how the grids will be appearing. Once this is done, now we need to understand some of the basics of contours. So, as said, your scale of the topo sheet is 1:50,000, and so you are dividing the grids into 2 centimeter to 1 kilometer. Now, one more thing that we need to consider in reading all the contours within a topo sheet is the contour intervals. So, this is one of the important points that we need to consider. So, first let us understand how to read contours, and then we will be seeing how this 20 meter is going to see. Now, we can see some of the visible values like 500, 500 here, 600 here and 700 here. All these are called as visible contour lines. Say for example, you have all the values represented, and to the sides you can see there is 500 also here. Carefully zooming in, we will be able to see some of the other contour lines that are present within or above the contour lines that are present. So, how to calculate the value of these? So, now comes the role of contour intervals of 20 meters. So, how to do this? So, if in case, see to the example of 600 here, the one line on the above of the 600 meters will be lesser than 600, which means the line represents 580, and moving on further, we will be able to see one more line which represents 560. So, in order to achieve this, you have to look into the other grids as well. For instances, you take this grid into consideration. You have 700 here, you have 600 here, you have 500 here, and also in case of 700, you can see the lines crossing over this grid. Once this you can see, you can also see other lines, that is this one and this one. So, you need to calculate the value of that. So, this becomes your 700, and you can see there are a lot of other values that are present, which means your value of this line will be much more than of the 700. So, using 20 as your contour interval, this line will become 720 and this line will become 740. So, this grid is said to have 740 as its highest value and 500 as its lowest value. So, there are some other points where we can see 850 here, where we can see 855, 970 and 940. These are called as spot heights or benchmarks. So, what do we do? In case of grids having these values, we can automatically consider this as the highest value, that is the maximum height. And in case if you are not having any kind of these benchmarks, you can calculate the value with the help of the contour that is available in that particular grid. So, now what we can do is, once after you are ready and you understood what the basics of how to read the topo sheet in terms of contours, we need to carefully transfer all the contours that is present in the topo sheet to the tracing sheet. So, slowly transfer all the visible lines that is with values in your tracing sheet. So, tracing sheet, what it does is helps us identify all the visible lines. We cannot draw all the small lines that are present within the particular topo sheet. So, in order to have a base, transfer all the visible contours that are present, and once you are done with this step, you will be able to see a result of all the contours, that is visible contours, that is present within a particular quadrant that you have selected. Now, moving on to the step 5. So, I hope you remembered all the process till now and the one you have done with the tracing sheet. The same thing, like transferring the boundary of the quadrant that you have selected and dividing it into the number of grids. The same thing you are going to do it for 3 more times. And why are we doing that? So, in order to understand and easily understand and execute our manual practical. So, one sheet we are doing it for calculating the relative relief, and one sheet for recording the height values, and one more sheet for representing it in the form of a map. So, by doing this, we will be having 3 more additional A4 sheets with all the grids and one quadrant block. Now, moving on to the step 6. So, carefully take one of the A4 sheet now. So, as already mentioned, you would have all the grids and quadrant of it. Now, what we do in this is, we again divide each and every block diagonally, making it like a square, further getting cut it into 2 different triangles. So, why are we doing this? We will be seeing in the next slides. So, once after that particular grids which are diagonally cut is done, we are now moving on to the step of calculating the relative relief. So, after dividing each grid square diagonally, now carefully refer to the topo sheet. Once after you have your tracing sheet and topo sheet with you, you need to refer topo sheet as well and tracing sheet as well, and record the highest value in the upper half of the grid and lowest value in the lower half of the grid. So, how can we do this? So, this is your topo sheet and this is your grid. Say for example, we consider one of the grids here. You can see the value of 500 here. No other values are present other than 500. So, we can directly enter that 500 is your upper limit and 500 is your lower limit, which we will further calculating the difference of it. Or say we take example of this, as already we have saw this example. So, here there is a value of 500 and here is a value of 740. So, the highest value we enter as 740 here and the lowest value of 500 will be entered here. So, by repeating the process of all the grids, you will be able to see and get a result like this. In step 8, what we are doing is we are recording all the values of highest elevation on the top right corner, and we are marking the lowest elevation value in the lower half. The next step is the calculation of relative relief. So, Smith, he identified, he placed everything in the form of grids, and the next step what he did was he gave a formula in order to calculate it easily. So, in order to calculate the relative relief, he found the difference between the maximum height and the minimum height. So, by using the formula, we are now going to calculate the relative relief that is present. So, this is the base sheet that we have already prepared, and now this is one of the other A4 sheet that you are going to use in order to enter the values. So, let us take this case. So, here you have 540 and here, at the lower bottom you have 460. So, by substituting all these values, say for example you have 540 here and you have 460 here, by subtracting you will be able to get a value of 80. So, once you got a value, you start entering into each blocks. One more example. So, this here the upper value is 440 and the lower is 420, you will get a value of 20 here. So, by repeating all the process, you will be able to get a square that is filled with all the relative relief values here. So, this is the example. Once you are using all these formula and implementing the values here, you will be having this one wholesome grid. Once after this, we are now ready for preparing our relative relief map. So, moving on to the step 4 of this session is the preparation of relative relief map. So, we got a lot of values, and this is one set of example in our previous slide. So, here as you can see the value ranges, it is like very easily we can say that it is of regular intervals. So, even if your values are regular interval or irregular interval, it is very important to understand that we need to group all these values into 3 or 5 based on your choice. Why is this so? Because Smith, he calculated and grouped all these categories of terrains in forms of 3 categories or in terms of 5 categories. So, in order to execute this, we now have a class interval of 3. So, in order to identify the class interval of this particular graph that we have right here, we need to sort out what the highest elevation value within this range. So, we have a value of 320 here, moving on to which we need to understand the lowest value as well. So, here we have 320 in this case and 20 as the lowest value. So, now the formula for calculating the class interval is highest minus lowest divided by the number of desired classes. Number of desired classes, as already mentioned, if in case you need it to classify it as 3 classes, you have to have it as 3, and in case you need to calculate 5 classes, you will be substituting 3 instead of 5. So, once after this is done, this value of 320 is entered here and the value of 20 is entered here, which is now divided by 3. So, once this is subtracted, we will be getting 300, and once divided by 3, we will be getting a value of 100 here. So, this becomes the base of classifying your class interval. What does it mean? So, 0 to 100 will be one of your class, 100 to 200 will be included as your another class, and 200 to 300 is your final class in case of having it as a 3 class. Now, moving on to other world situations where you have irregular values. Here you can see in this graph we have 66, 501, 652, and how is it possible to classify into 3 class? The same formula. So, identify the highest value within this, which is 1093 here, and in case of the very lowest value we have 18 here. So, now substituting all these, so 1093 minus 18, and here also we are going to obtain 3 classes, of which we will be getting a value of 358 now. Once this 358 is done, we will be now fixing our classes, that is 0 to 358, 359 to 717 and 718 to 1093. So, based on the values that we have obtained with the form of class intervals, we are now going to group all the values within this particular map. Once after all the class intervals has been assigned, we are now grouping it into different groups based on the categories that we got. In case of this, we have 0 to 100, 100 to 200 and 200 to 300. So, as you can see, there are a lot of values here which ranges. So, once you identify all these groups, with these groups we are going to now plot a line here. So, this you call it as a form of interpolation technique. So, here what I did was these are values that are going to be falling in the category of 0 to 100. So, I am plotting this as one of the category, and in case of this one you have 240 and 320 which will be included in a category called more than 300. And once after doing this, all these lines will be recorded here. There is one more example of a sheet where you have values of regular intervals. So, as you see here, we have values of 50 here, 100, 150 and 200. So, the maximum value that you can see in this image is 200. So, you can easily say, like, you can classify this map as 0 to 50, 51 to 100, 101 to 150 and 150 to 200. So, this becomes a classification group of this particular slide. So, once after you are fixing the group, you are now going to group all the values that fall within this category. Here you can see 50 is one of the value that is present in this whole area, and so we are marking a line along the 50 here, and you can see 50 the same here, wherein you are carefully plotting all the 50s here and bringing the 50s into one categories. So, you can see some of the other values that is like marked in the form of one single line which is very small. So, here this means that value here is of only in one place, and you can see 200 here as well. So, in such cases you will be easily plotting it as one single line that covers that particular value, and in case of this you have hundreds here, the value that connects 100. So, once you are clearly drawing all the lines and connecting equal points here, you are now going to be involving in a process of shading or filling patterns for the same. So, this is the base map that we got by drawing all the lines, and this becomes your output. So, in one of the A4 sheet, what you are supposed to do is carefully trace only these lines that we actually draw into the map. Now, we have to draw this into the another and fresh A4 sheet. Once after you are done with this, you will be able to see all these lines in the other topo sheet. So, here as already mentioned, we have class ranges, that is ranging between 0 to 50, 51 to 100, 101 to 150 and 151 to 200. So, what Smith did was, he, in order to understand different terrains that is placed within an area, he gave a classification and a series or a set of values within which all these values will be classified as very low relief in case if a particular area is said to experience lower than 20 meter of the relief. If the value is ranging between 20 to 100 meter, then this will be your low relief, and in case of 100 to 300 meters, it will be a moderate relief area, and in case if an area is said to have 300 to 900 meter elevation, we will be representing it as high relief, and if there are areas where it experiences more than 900 meters of relief, we will be classifying it as very high relief. Once you can see this map, we have values which are classified only within 200. So, what you can say is the maximum relief that is present is moderate relief. So, you can say undulating relief here. If in case you have values that are said to be within 51 to 100 or within 101 to 150, we will be classifying it as plain. And once if the values are moving more than 300, we will be classifying all these as rugged topography. So, this is one of the key things that we need to understand in terms of relating with the relief that is present in a given area. So now moving on to the real world scenario and the application of this relative relief. So one of the basic and important application that we are using this relative relief is in understanding the geomorphology and landscape analysis. As already mentioned in the starting of this slide, we said that geomorphology is one of the important thing that we need to understand and have in mind, as it says the history of every characteristics of the terrain that is present before us right now. So what does it mean? We have a lot of rivers, we have a lot of valleys right now. So before like 1950s, what was the condition of those things? So in order to understand that, we can use relative reliefs in order to understand the history, evolution and the development of those. The next one is hydrology and water resources. In case of hydrology, we will be using it in order to understand the characteristics of a watershed. So how the denudational process is acting, how active that particular area is, in order to find the classification of the soil that is present, the type of the soil that is supporting that particular area and the water holding capacity that it has. So all these that we can say it with the help of the relative relief. Then moving on to another application, that is environmental monitoring and conservation. So in case of conserving all the resources that we have, we need to understand how slopey it is, how plain it is, how flat it is. So it is very important that we need to understand all the types of topography that is present within an area, and to do so we are implementing relative relief here. And also we are saying about slope stability. This is nothing but analyzing your landslides. Say for example, you are about to expect a landslide here, then there is some alterations that is happening within that particular area regarding the slope. Once the friction that exists going to be cut off, all the rocks that is standing here will be falling down. This can be analyzed with the help of the relative relief that is present in an area. The next one is disaster management, as we have seen a lot about this, and the final one is the resource management. So the key takeaways of this session will be, we have a lot of understanding now on what relative relief is, what it represents as the variation within a particular defined grid without considering the sea level, and how Smith in the year 1935 he classified and represented in the form of grids, which is divided into 2 centimeter into 2 centimeter, and how we calculated with the help of the formula that he gave, and we represented in the form of a relative relief map. Thanks for watching.